Okay, Bob, you came today with some show and tell, and I'm super excited to see the thermal spray process. And you brought some images and video that I'm excited to go through. So what's happening here in these images? We'll start right here with this image.
Yeah, so what I want to do is put together a series of photos, a little bit of video to show you a typical repair and probably one of the most important repairs that are being done out there today, every day in thousands of shops across the US. So this is a shaft, and where you see that area about it's about an inch inside, it's a smaller diameter.
Hmm.
That's a bearing and a seal surface. That what happened is this shaft was in service. The seal wore out. There's a seal that protects the bearing, and water or something got underneath that seal. It caused the bearing to fail. The bearing locked up, and the motor stopped. It might have been a pump, and it caused damage on the shaft. So they got the bearing off, and in the process, they may have used a torch. Who knows how they got it off? And they put this shaft in a lathe, and they machined it undersized. Now, this is machined undersized about 20 thousandths of an inch. It's almost like the perfect repair. And then they grit blast it. So it has that like silverish look. That's a grit blast surface. And they had used a 60 grit, which is a little finer than I like, but they did a really good job on it, and they did get good adhesion on it. This is the guy actually spraying it. Now, he's using twin wire electric arc, and he's spraying that area up using a stainless steel. Actually, it wasn't a stainless steel. It was a type of stainless steel, but it was a material that was what we call self-bonding. It was more than just a stainless. We had some aluminum and chrome in there that helped with the adhesion. So he sprayed that part, and if you take notice here, it's actually a lathe. It's enclosed in a plenum, and there's a dust collector now pulling the dust out. And he's wearing protective gear. He's got a hood on there so that it's a welding type flash. So he wants to protect his eyes. He's got welding gloves on so he doesn't get sunburn. He's got long sleeves on.
Does that unit there do well at for sound issues? Like, is that to help contain the sound, or is it still just very loud at all times?
It's still very loud. That enclosure is to take the dust out, which is actually metal floating in the air.
Okay.
And by doing this type of hood design, you can minimize the size of the dust collector and still have effective removal. You can't see his earplugs, but he's wearing earplugs. It's loud.
Okay.
In this particular case, he is using twin wire electric arc, but you could use plasma to do this repair. You could use combustion powder. You can use combustion wire. You can use HVOF. So all the different thermal spray processes could be used here. It depends what the end properties are that you're looking for, how you would choose what material and what piece of equipment.
So what do we got going on here?
So this is the shaft after it was sprayed, and you can see it's got that rough texture to it. That's the typical thermal spray surface. It's probably like an RA of 130, pretty rough. And you'll see that you still see that indentation, but what he did, he sprayed it so that he put more material on than what the depth of that initial machining was. So when he puts it in the lathe and machines it off, you'll see eventually it'll clean up on the original shaft. And you can see here where they machined off the thermal spray and the surface in the center there that has the rougher texture, that's where the indentation was, and it's starting to clean up now. And they machine it down to the original dimension. So basically, they machine off all the thermal spray on the original surfaces that were not at a lower diameter, but you can see they're right in the center. That has a little bit different color. That's the thermal spray buildup. So this shaft is restored back to its original dimensions. They'll slide the bearing on there, and they'll put a new seal on, and they've saved this shaft. So in this application, if you have a pump, and again, an example is we have a guy who pumps salt. So he has a $40,000 pump. He wants to save the pump. We have an example where there was a water pump for a major metropolitan city that had one of these shafts that was 9 inches in diameter. The pump was worth $500,000. Same problem. They had the spun bearing. They repaired that large shaft, and they saved, a $500,000 pump. If you saw anything today with the automation or the processes that has your interest, give us a call at Thermal Spray Depot at 724-229-5791 or drop us a line at info@thermalspraydepot.com.